And yeah, this bit should be quick, so you can ignore that. First, I really wanted to look at some common latencies that people might experience here. So the average typist is something like, I forget, is it 6 characters a second? No, it can't possibly be that. That's a fast one. So they're really quite slow, 3 characters a second, right? Not very good. The protypist is getting much more around I think 6. I type at about this quickly. I'm proud of that. Of course, it's not very accurate, but it looks good, you know. If you mash the keyboard, you can go about 3 times, you know, about 10 times faster than the average typist is just you banging the keyboard. So if you're testing our software by banging the keyboard, just be aware that you don't need the other 9 people to simulate the performance, right? And here are some latencies. This is a log plot. For those who don't know what log plots are, go and read it. Read about logs. They're great. So yeah, your Bluetooth keyboard latency, for example, Bluetooth is, people often don't know how quality Bluetooth is from a latency perspective, but you know, it's about 30 milliseconds. So you can go Frankfurt to London faster than you can go from your Bluetooth keyboard to the CPU next to it. Okay, so that's pretty bad. Of course, yeah. So even a wired keyboard, if it's really going for it, can take about half that time, which is quite funny because a frame time, you know, just to refresh the screen, where are we there? 60 hertz frame time. Yeah, so like it's also quite slow, surprisingly. If I push these through. Well, let's measure some people first. So the human eye blink, it varies. So apparently Americans blink at 400 milliseconds. Europeans blink at 100 to 200. I don't know why. I think it's the pace of life or something, or just different studies. But I'd like to measure you. So when I press this button, there will be a green rectangle will appear on the screen. And this is the point where you can exercise, you know. I mean, I know it's a very sedentary lifestyle of being a programmer. So what I want you to do is start blinking really fast, okay? And hopefully your blink muscles will grow and bulk up. And when you see red, stop. Oh, and if you can count how many blinks you do at the same time, that would be good. Are you ready? It's a complicated task, but we basically got it, right? I press the button. As soon as you see green, start blinking. And then when you see red, stop. And then you have a number. Okay, are you ready? We got it, right? Ready, steady, go. Okay. What did you get? 4, 5. Ooh. So I have some advanced mathematics here. This is how to divide, you know, 1 divided by things. So if you saw 1, I can do that one. That's easy. But most people are around somewhere here in the middle, 5 or 6, something like that. Is that yeah, common? I mean, there's obviously some people who are getting 130 because they're a peregrine falcon, right? But okay, so this is, you know, like 5 or 6 is not too bad. Like that's 200 milliseconds a blink, 167. So when we come back and look at that, you know, like the very fast blink at 100 milliseconds is pretty much the same time it takes, you know, to get from Frankfurt to the East Coast and back again on the internet, right? Like that's the ping time between these data centers. Maybe you know, you're 6 or 7, then Frankfurt to the US West Coast is something like that. And the protypist is, you know, struggling to type at the same rate that you blink. Probably there's no coincidence there. So yeah, so it's interesting. So in the blink of an eye is quite an interesting metric. Anyway, so this hopefully grounds some of the talking about this, and I've probably run out of time already. Anyway, don't optimize before profiling. I was coming back to that. So yeah. So one of the things that's interesting in life is that perception is not performance necessarily. So one of our largest improvements in perceived performance was making things slower and was waiting more time for things to come off the WebSocket before rendering, which is quite funny. So people perceive things differently, tearing and so on. Yeah. So and if you see the invalidation rectangles rendered in the debugging mode, you'll see how amazingly fast they appear, you know. But yes, so it's pretty difficult to measure things. So often we have this feel metric, and we're really looking forward to Neil's wonderful Valgrind-based performance things. But CPU sampling is not everything. We try and improve CPU performance. I think there's a talk about that shortly. But we also have these slow burn profiling things that are running all the time on our demo servers every second that we're sampling the stack trace. And Noel was talking about getting enough data. So we run that for about a week, and then we see what's happened on the demo server. And we also have some tracing tools that we can use to look at particular interactions. And you can turn those all on here. So if you go Control-Alt-Shift-D or triple click in Help About, you can see all sorts of clever things, and you can start to see what's happening with tiles and where they are, and have they been refreshed, and were they the same? Were they pointlessly refreshed? I think that's the yellow bit here. We managed to render the same tile again and then send you a message saying it didn't change, and so on. One of the things I'm most excited about, and I think it's going to have one of the largest impacts on where we're going to improve latency, is this thing. So we have a magic variable now we can export. Cool, watchdog equals 1. And what this does is it runs a little thread, and the thread sits there, and as soon as some thread or document or piece of the program is not responding, or it's busily doing something, but it's essentially not responsive, it starts to call a magic system call identified by Quaylon, wherever he's gone. Yes. And then Perf can get this system call and give you stack traces for that thing. So there's a bit more complexity and signals and good stuff. But the good news is, so essentially it's measuring the time that you're not yielding. When you're yielding, you're waiting for things to happen. This is good. Your computer should be idle all the time. It shouldn't be doing anything. It should be waiting for your next command, obviously. And so it measures this time here, and if it's too long, it starts sampling it. And the initial results look really, really promising. So this we don't really care about. This is the admin console looking at, this is a flame graph, incidentally. Thank you, Noel, for your introduction of it. So this is time on this axis. This admin console we don't really care about. It's not really an interactive thing. It's just measuring all sorts of stuff. This guy here is people joining sessions and downloading documents, which is kind of slow. The good news is Ash has done a whole lot of work that he'll tell you about at some stage later. So there's some good things there. And unfortunately, this is only the server side. So we need to get more into the kit process. So there's an end-to-end tracing tool as well, which is kind of nice. And here's some of the things that we've improved in the last few months. So we're doing a lot more aggressive tile caching in the client. So previously we would routinely throw everything away and then re-render, and now we really don't. We tend to think an old tile is better than nothing. We do quite a lot of re-rendering of things we already have, and so we're now keeping, well, just a lot more of these. I think it's 1,000 or so tiles or so in the client, and they're just much better compressed, so they're really, really much smaller. So we have 1 to 2,000. I think there's a low and a high watermark, something like that. And we keep those in a tiny compressed form. We manage our canvas memory better, so we have a few of them uncompressed big, as it were. And yeah, JavaScript garbage collection is not your friend. Before you know it, you run out of canvas memory, and bad things happen. And yeah, you can't get it back easily either. So there's some good fun here shepherding that, making that work nicely. Yeah, on spreadsheets, we now keep the other sheets. So we cache views of other sheets and we invalidate them. And in Impress, we cache views of all of your slides. So if you're running through a slide deck, we can have it pre-rendered. So as you move through slides, it's always rendering the next slide and maybe the next one ahead. So it's there ready for you as you move, and then it's just very low latency. What else? Aha, yeah, so I said essentially this. That's fantastic. And that too, good. That's speeding things up. And you see latency reduction. We talk about the next slide before we finish. Never mind. Okay, perfect. So continual style. So there are a number of things here that are particularly silly we found. So one of the things was when you joined, lots of people joined a document. An unbelievable amount of time was spent doing the beautiful thumbnailing of styles in the bar, and probably font previewing as well, and all this good stuff. And wouldn't it be nice if you could cache that, do it once, and then just send it to people? So that's pretty good. And there's also, why don't you just let them see their document before sending all of this data to make things pretty? Ash has got a great talk on this later. Looking forward to it. Background safe. I've got another talk, which you will suffer through, perhaps. And then, yes, trying to make this smaller. So getting deltas instead of sending huge chunks of JSON for dialogue. So Shimon's done some great work on that, I think. And there's probably more to do. And then trying to get JavaScript, the size of the JavaScript down. So there's some great work there, getting rid of dependencies. Yeah, I mean, we have lots of end-to-end traces if people want to read them and go, oh, that looks silly. There's quite a lot of, yeah, just look at it and see if there's some silly stuff. And yeah, and there's some other cool things that Heiko should want. Heiko, here is your chance to get glory. I mean, it would be really nice just to see all of the commands that people are actually using. So we can do that on our demo servers easily and log everything that everyone's used for the last month, and then get some idea of the relative importance of stuff without leaking any confidential information, of course, across a large group. So that'd be cool. So we should probably do that. And that's me. Thank you.